Here we go. So thank you. I'm pleased to be here and speak with you about the present and also about the future of building culture. Just quickly, I would like to show you one work of our architecture office. It's the Nest research platform, which we have done for the EMPA, the Swiss Federal Material Science and Technology Institute. And this building is unfinished, although our commission ended. So this building is a building which is in process. It's a building which ought to be extended by different other buildings, and thus it constantly changes. And I show you this project because I would like to kind of open a bit your senses towards the design of processes, the possibility to design processes which are open-ended, which can have potentially multiple authors and multiple contributions. I think we've had some discussions on this before. So this is the section, and you see a lot of, if its outbuild is missing, indeed we don't know how the facade will look like, and that's one of the more recent pictures of the building. You see it starts to be filled in. These are all inhabited research units used by guest researchers of EMPA with different thematic research areas. It's really a bridge between research and industry to create inhabitable houses with thematic areas which otherwise wouldn't be built out in our cities yet, but can be tested on this changeable platform. I would like to switch to our research, which we conduct at ETH Zurich. There in 2005, we started with the Professorship for Architecture and Digital Fabrication, together with Fabio Gramazio. And this was our first installment. We brought a robot to ETH Zurich. Now you might think, what are these architects up to? But why did we do this? We were interested in the combination of the material practice of architecture together with the computational practices or possibilities that we have nowadays. Now, you can only do this by linking this up through fabrication. And what you actually see is, if you link the material and the digital by fabrication, that you end up with a new materiality of architecture. We call this the digital materiality. It means that the material as we know it becomes informed. It changes. The digital processes are as present as the physical material processes of creating that material. It leads us to a rethinking of construction. We will build differently with digital materiality than we build today with the conventional craftsmanship. It leads us, and this links back to the Nest building that I've shown you before, to the design of processes rather than the design of forms. And surprisingly, maybe if you use a lot of digital technologies, actually it increases and opens other possibilities for a material sensuality and presence in architecture, something which we might have lost over the decades of industrialization. I show you some examples, mainly from transfer from research to research demonstrators, to exemplify this quality through built work. And making this transfer is also one of our methods to actually develop what we actually call a digital building culture, to actually exemplify research and put it out there in the built environment and to have discussions about it. This building, designed by Bert and de Platz as architects, and the facade designed by us for it, is the Gantenbein winery. And the facade that you see here is composed of bricks. And these bricks are robotically aggregated. Here you see the process. You see the robot gently places some glue on each brick, And he puts that glue exactly at the interface to the lower bricks, and each of the bricks can be slightly rotated. It's only 17 degrees, up to 17 degrees in one or the other direction. But this slight rotation in the sunlight is enough to give you this impression that you saw before of these oversized grapes of this winery. And if you go closer, what is nice, this overall, let's say, iconic expression dissolves in favor of the presence of the brick, the material that this facade is made out of. Here I give you an impression from the inside. And this building, built in 2006, might be the first Swiss instance of what we refer to as a digital building culture. Then, at ETH Zurich, we had the possibility to make a step further, to actually go beyond something which you could still say it's ornamental in its quality, but not very performative. We had the possibility to do the roof of our institute building, which you see here. This institute building is a densification of an existing parking lot underneath. So we densify the campus, and it's a building designed by the professors of the institute for themselves. So we contributed the roof to this project. Here you see an image of this roof that's composed out of 50,000 different slats, which are arranged in certain manners. I cannot go into detail with respect of time, but I would like you to show you this plan. Not because we design in plans, actually we don't design in plans anymore, we design through programming. But what you see here is the qualities that this digital kind of brings into planning. You see this softness, this gradual changes, this adaptivity. You see how at some places like a textile, this let's say fabric tears a bit apart. At other parts it compresses. So you see that it has a certain behavior, and that's again this design of processes. This behavior is then very pragmatic. It's densifying where it meet columns. It's stretching apart where air ducts need to go through the roof, etc. It adapts to multiple of the requirements, including lighting, water, etc. This is the build-up of the roof. So it's, as I said, composed of these 50,000 slats, and this is how it is made again. You see, at an industrial partner, we managed to convince him to build a machine, to build this roof, and now he can do other projects with these digital technologies. Basically, you see a layout of layer by layer slats, and the machine that gently kind of cuts these slats, put them on top of one another, executes a nailing pattern, and this is structurally informed. So this could only be calculated on a computer and cannot be actually done by hand. So you literally need to try many nailing patterns to understand which one actually works and transfers the forces. And then you have building products such as these. So that's a 13-meter long beam that is basically 3D printed, but instead of powder and binder, it's timber slats and nails which hold it together, and it's stocked here to then be placed as a functioning building element of our institute. And I welcome you to come by anytime. That's where we now work. These are the working places of the PhD students at the institute. So we gradually start making the digital integrative reality of an architectural design process, but also a constructive process from the bottom up. And the last of these demonstrators, which we realized, is called the Dff House. The Dff House has been realized in partnership of ETH Zurich, the EMPA, and the National Competence Center for Research in Digital Fabrication, which I had the pleasure to initiate. And it's actually done by a number of disciplines. So this is not architects alone let's say, toying around with robots and machines. This is really starting to get an interdisciplinary collaboration where different aspects of technology and aspects of architecture meet as a contemporary approach to architecture. It involves many people. So in this case, over or close to 50 researchers, technicians, and others that have actually contributed not only to the concept and execution of this, but also to the design of this. So this little building, which I'm going to show you here, doesn't have one architect. It has a multitude of architects, by definition. So here you see this building. It's a little 3-story building, and it's situated on the building that I've shown you before, on Nest, on a nice corner parcel. And it incorporates multiple research projects, which you see listed here. And I'll quickly walk you through to give you a sense of what is in this little house. So think of this architecture now not being conceived top-down. So there's not a design idea which you then sketch out from, you know, through your different scales up to an execution plan, but actually you start with the execution. You start with the research. You start with how would I want to build something? And then from research, we actually take it in the question, well, where could these different research parts end up with in a building, and how could all that get back to architecture? It's a strange approach, I acknowledge, but I think it is an interesting one in the times that we live, in particular with respect to the ecological crisis, where I think we need to work much more from the material practice and from the material resources on backwards towards design to give meaning to those designs, instead of just creating the meaning up front, publicizing it, marketing it, and then somehow building it. So let me start with the first one. This is mesh mold. This is a formwork-free concrete building technique. Basically a robot, well, I'll show you in the video, a robot builds a mesh. This is our PhD student, Katrin. Builds a mesh, and this mesh is very fine-grained. This mesh can then hold concrete. So you see the robot builds this form. It doesn't need any plan. It's a human-machine collaboration. It's usually 2 humans, 1 robot. That's roughly our ratio. So there will be new jobs to answer this beforehand. And here you see this building process where the robot not only produces this mesh on site, but also gives it form. And this form, of course, can be informed by multiple criteria, in particular structural ones in this case, but also architectural ones, as this wall is the only wall that is supporting the upper floors, but that's also actually dividing the space of the ground floor of this living unit. Let me jump a bit ahead. No, I can't do that. Good. Here you see the filling. So this is again a human-machine collaboration. So the robot is built with this. The mesh is built with this digital procedure. The filling is done manually because we figured out this can easily and actually better be done by humans. And you see how this mesh is now filled, and that you don't need any formwork to sustain the pressure of the liquid concrete. That is the real innovation, and that's actually the contribution to sustainability that this project makes. Then final layers are added, and the finishing touch in this case is also done by human craftsmen. And so here we talk about not building the building twice, once as formwork and then second concreting it, but actually just doing it once straight away. So this is this process. These are our happy researchers to share this also with you. Another concreting process is smart dynamic casting. We employed these for the facade mullions. This is a process where only a minimal formwork is being used. You see this formwork slips up and releases concrete just underneath. And this concrete is just in the right moment where it's about to harden, but it's not too hard so that it can still be shaped. So it can be brought into a differentiated form at that moment. And here the digital does something else. It allows us a level of control to work adaptively with material that was not possible before the digital. So again, our approach to the material reality of architecture and the processes on how architecture is built changes. And then these columns are produced, or facade mullions, so they're not load-bearing, and inserted. And then we have a third concreting technique, that's the so-called smart slab. Here the formwork technology changes. This is the slab. It's like a table cantilevering off the mesh mold wall. And this table now reacts to the wall geometry. So whenever you would change the wall geometry in the design, actually the table would change its form. And it would do that through a computational design process. So despite that these were different research groups designing these entities, if some group were to change something, the next group's project would automatically adapt. That's a radical shift for those of you that do architecture in the way that we currently plan. So this is how it is looking. This project has been done by the research group of Professor Benjamin Dillenburger. You see the group studying the project, these two different building components coming together in rendering, actually the three different concreting components. And here is how the project is built. This is built with a formwork that uses 3D printing. So you see here a 3D printer printing up formwork elements. Then these are being unearthed. I don't know the right word, how you say that in English. So basically cleared off their printing bed. And afterwards, these pieces are assembled to the full formwork size, which you see here. And you can already see the high degrees of details, the level of expressivity that is part of these wonderful 3D printed formworks. And so that is then concreted with a very thin shell. This is only about 2 centimeters, if I recall correctly, of a first concreting shell. And then later, there is another part of formwork put into place on which rib elements are cast. So again, the try here is to see what aesthetically can be done with these technologies, how it factually works, but also to improve the efficiency and potentially the ecology of building with concrete. So if you can start to integrate many aspects in a concrete element, if you can give it specific forms that are optimized in material terms, you of course have a big environmental advantage. Good. Here are the expressions on the concrete side. You see how the architecture of working with concrete changes by changing the practices towards digital fabrication practices. Now I got the 1 minute note, so I'm gonna skip through this. So you can do the same thing with timber by building spatially with timber, directly with using robotic arms. If you build spatially with timber, you actually get stiff structures which are reminiscent of old timber houses, which then call for other facades because you don't need any stiffening facades. In this case, we developed a membrane system which can be filled with aerogel that is only 9 to 12 centimeters thick. And then the material expression of filling that results again in this very beautiful expression of the material itself, this marble-like quality. And here you see some impressions from the inside. Dff House can also be visited, so I encourage you to do that. Now, to sum up, I would like to show you a last project, and actually not the building of it, but the building back. I was telling before that I think to go towards this digital and material practice is important for ecological reasons. And this pavilion here that you see is built only by gravel and strings with a roof on top. So what you see here is just loose gravel and strings. And I would like to show you how this pavilion was built back, because this pavilion, once you take the roof off, is fully reversible. That means its materials can fully be reused and are in the same quality as before. What you do, simply you pull out the string again that was used by the robot to build up this amalgam of string and gravel to build this structure. So basically you reverse the process, the construction process, and you end up with a pile of gravel and the spools of string. Good. So a digital building culture, to the current moment, I would say it's an active, maybe proactive architectural design culture that is inclusive of digital and physical processes and the resources thereof. And how to promote such a digital building culture? I think we should strengthen contemporary architectural research. We should create interdisciplinary research centers, ensure digital literacy in education of architecture, engineering, and construction. We should introduce creative programming and architecture, was mentioned before, in primary schools. We should support architectural open source coding communities. It's not really existing yet, but starting to emerge. We should foster computational architecture studio. It exists in little numbers, but it exists. And we should invest in innovative flagship projects. Thank you for your attention.
Thank you, Matthias.